Okay. Hi everyone. In today's video, we are going to be treating block diagram reduction rules. Block diagram reduction rules. Why block diagram is always required in every control system. So, but first of all, what is block diagram? Block diagram is the pictorial representation of each and every component in control engineering or in a control system. So if any control system is given a block diagram, that means that it tries to bring an indication of components like the signal flows, the branch points, the summing point, and so on and so forth. So basically, we all know about the transfer function, which is the TF, which is actually the ratio of the input and output. So if we have a small block intermediate between output and input, then it is very easy to get the overall transfer function. But whenever we are having a numerous number of blocks, you cannot estimate the TF or the transfer function of that block because it is complex. So dealing with complexity of blocks, we have to introduce the block diagram reduction rule. So the block diagram reduction rule is very important in reducing blocks into one. We are trying to modify numerous number of blocks. We are trying to make it to become one. We are going to pass through number of rules would guide you, would enable you to know that no matter how complex that block is, we can be able to reduce it. So first of all, the first rule is combining blocks in series. Combining blocks in series. So these two blocks now, we want to bring them together. So whenever you hear about combining blocks in series, you don't consider them individually. Remember that our intention is to get the same output. So if we bring G1 and G2 together, we have gotten the same output in respect to what is being inputted into that blocks. So we are combining two blocks in series. So whenever you hear series, it simply means we are going to multiply those blocks. So example we have A, which is the input into G1 and G2. So G1, A, G1, and G2. So this is in series now. So we are going to multiply these two blocks. So what we'll be having is G1, G2. So the output is what? AG1, G2. So we have brought two blocks, we have made it to become one, and they will act the same function. They will give the same output. So for the second rule, it talks about combining parallel blocks. Combining parallel blocks. Whenever you hear about the combination of parallel blocks, it simply means, whenever you hear parallel, it simply means you are going to add the blocks in one block. So we can say A, this block now, we say A, G1 plus G2. So our output will be what? A into bracket G1 plus G2. Or you can say A, G1 plus AG2 is our output. Now the third rule talks about moving branch points ahead of blocks. Moving branch points ahead of blocks. So these points now, this branch point, we want to move it ahead of this block. We want to move it from here and drop it towards this place. So whenever you are moving a branch point ahead of block, if you want to move that point, you must add a block that is the inverse of the actual gain. So this now is the gain. This is the gain. So whenever we are moving this point ahead of the block, we need to add the inverse of the actual gain. So let me show you here. Example of adding the inverse of the actual gain. We have A. So this is the gain, the actual gain. So we are moving this point now ahead of the block. So we put this point over here ahead of the block. So what we are having now is what? 1 all over G. That is the inverse of the actual gain. So whatever you are doing must always affect the block. Anything you are moving, just know that there must always be an effect in that block. That particular block you are moving, whether you are moving a summing point above or you are moving a point ahead, it must surely make an effect on that block. So this is for the third rule. And let me say the output it can be given as AG times 1 all over G. So this is our for the third rule. Now we move over to the fourth rule. It says moving a branch point before the block. Moving a branch point before the block is no longer ahead. So in case you were given a block diagram and it was looking so cumbersome, let me say moving a branch point before the block may be the solution to the problem. So see what you're going to do now. This branch point is ahead of this block, like stated in the previous, is ahead of the block. We want to push this branch point to move before this block. So what we're going to do is we say the branch point, which is G. So this is what we are going to have, AG and AG. So rather than adding inverse, you see, as we move this branch point before the block, rather than adding the inverse of the actual gain, we rather add the actual block, that same block, actual block that is there. We rather add the actual block. So the next rule we have is moving summing points ahead of the block. Moving summing points ahead of the block. In this case, we would add the actual gain. So always have this at the tip of your finger. Whenever we are moving summing point, we want to move this point now. We want to move it ahead of this block, the way we did for the row 3 and row 4. So we want to move this summing point ahead of this block. So see the results it will give us. So we have B as the input. Then this is the gain. We have A. Then G. So this is the summing point. We finally moved this summing point ahead of the block. So what we have as the output is AG plus BG. So moving summing point ahead of the block, you add only the what? Actual gain. So in rule number 6, moving summing point before the block. So moving summing point before the block, normally you have to now add what? Inverse of the actual gain. So now we want to move this point now. We want to move this point before the block. We want to move the summing point before the block. So what we are going to do is, the result we are going to have is B 1 all over G. So plus. So we have G. So our output is what? A, G plus B. So look at it here. This is our A. Or you can put it, for this gain now, you put it A plus B all over G. So that is for rule 6. Whenever we are moving summing points before the block, we consider this. Now for rule 7, we say interchanging summing points. For rule 7, interchanging summing points. So you can also say that interchanging summing point, we have A plus minus plus. So we want to interchange this summing point. So what we have here is A minus C because of this negative sign. And so this is the output, A plus B minus C. So you see that this one was over here and this one was, so we interchanged it. We interchanged the summing points. And also, I also witnessed that you can also interchange the moving points. You can also interchange moving points in block diagram, or you can call it branch points. You can interchange those points, but it does create an effect. But when we start modifying blocks, when we start going through the problems in block diagram, I will show you how those lines would also create an effect. At most times, it doesn't create an effect. The next rule, the number 8 rule, we have splitting summing points. Splitting summing points, we have the result is going to be B, A. So let's draw the summing point. So whenever you are giving 3 signals, and you are modifying a block, you need to, if it's giving you a problem, you need to split the summing point. So the result we have here is, cancel this minus. So the result we have here is this A plus B. So we have splitted the summing point. So we have plus minus. So this is C. So what we have is A plus B minus C. So thank you very much.